frequency shifting property. State and prove frequency shifting property. First one, state and prove frequency shifting property. So first we write down statement. If x of t, its Fourier transform is x of f, then e raised to j2 pi f0 t into x of t, it is x of f minus f0. So we have to prove it. This is the statement. Now according to the definition of Fourier transform, we write down according to definition of Fourier transform of x of t, it is x of f minus infinity to infinity x of t e raised to minus j2 pi f t dt. So this is Fourier transform definition. Now Fourier transform of now e raised to j2 pi f t 0. Therefore, Fourier transform of e raised to j2 pi f0 t into x of t, it is equal to minus infinity to infinity e raised to j2 pi f0 t x of t e raised to minus j2 pi ft dt, which is equal to minus infinity to infinity x of t e raised to minus j2 pi f minus f0 into dt. So we can write this equation as x of f minus f0. Therefore Therefore ft, that is Fourier transform of e raised to j2 pi f0 t x of t, it is x of f minus f0. Now the term x of f minus f0 indicates shifting of the signal in frequency domain. It indicates shifting of the signal in frequency domain, and it is also called as the shifting of spectrum. So the multiplication of the signal by e raised to j2 pi ft0 in time domain is equivalent to shifting the frequency spectrum. Now second one, state and prove differentiation in time domain property. Time domain property. So first we write down the statement for this. If x of t, its Fourier transform is xf, then d by dt of x of t, it is j2 pi f x of f. Now the proof for this. According to definition of inverse Fourier transform, we can write xt is equal to, it is minus infinity to infinity x of f into e raised to j2 by ft df. We can write this equation. One. Now differentiating both sides with respect to time, we write here differentiating both sides with respect to time. So d by dt of x of t is d by dt of minus infinity to infinity xf e raised to j2 pi ft df. So it is minus infinity to infinity x of f d by dt of e raised to j2 pi ft into df. So it is equal to minus infinity to infinity xf as it is its integration it is j 2 pi f into e raised to j 2 pi f t df. So therefore d by dt of x of t, it is equal to minus infinity to infinity j 2 pi f x of f to e raised to j 2 pi f t df. This is equation number 2. Now we can write this as this is IFT, that is inverse Fourier transform of d by dt of x of t. This is inverse Fourier transform of d by dt of x of t. So we compare equation 1 and 2. Compare equation 1 and 2. We can say inverse Fourier transform. We can say inverse Fourier transform of j 2 pi f x of f is d by dt of x of t. That is Fourier transform of d by dt of x of t is equal to j 2 pi f x of f. So in this way we can prove this differentiation in time domain property and compare to the magnitude of xf, that is mod of xf, the term mod of j 2 pi f xf is larger. So the differentiation in time domain corresponds to the enhancement of the high frequency components in frequency domain. Now the next one, state and prove integration in time domain property. In time domain property. So we write first statement. If x of t, if its Fourier transform is x of f, and if x of 0 is 0, then we can write this equation as minus infinity to infinity x of lambda d lambda, its Fourier transform is x of f divided by j 2 pi f. Now proof for this, the derivative and integration cancel with each other. We write here derivative and integration cancel with each other. Therefore x of t is equal to d by dt of integration minus infinity to t x of lambda d lambda. This is equation 1. Now to avoid the confusion, we used variable lambda instead of t. Here we use the variable lambda instead of t. So taking Fourier transform of both sides, of equation 1, we can write equation x of f is equal to Fourier transform of d by dt of minus infinity to t x of lambda d lambda. This is equation 2. Now Fourier transform of xt using differentiation in time property. Using differentiation in time property, the RHS of equation 2 can be written as x of f is equal to j2 pi f Fourier transform of minus infinity to t x of lambda d lambda. Therefore, ft of minus infinity to t x of lambda d lambda, which is equal to x of f divided by j2 pi f. So the integration in time domain is equivalent. The integration in time domain is equivalent to the division of Fourier transform by j2 pi f. That is, it is equivalent to the compression of high frequency component in frequency domain. So in this way we can prove the integration in time domain property. In next lecture we will see the multiplication theorem, convolution theorem.